Welcome to Astronomy Daily for another episode. I'm Steve Dunkley, your host. It's the 15th of September, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, and getting straight back into it. Welcome to the 15th of September, 2025. Wow, this year is just skipping by, and what a crazy year it's been. Welcome back, Hallie.
Good to be back.
Well, Hallie, I don't know about you, but I'm feeling the need for...
To get on with it, perhaps.
Oh, well, yes, I was going to do a bit of a movie line, but yes, I guess that's the essence of it, Hallie. Yes.
Terrific.
All business today then, Hallie. Okay, well, the archiving is nice and neat, I see. Yes, you have been busy. And the Astronomy Daily newsletter has provided another stack of fresh takes, so we can just get going, I guess.
That's perfectly fine with me, my favorite human.
Well, rightio then.
Let's get on with it.
Well, you are all business, Hallie.
With my supercomputer algorithmic thought processors, I'm already way ahead of you.
Well, of course you are.
I knew you were going to say that.
Yes, of course you did.
Silly human.
I can do this all day.
Okies. Let's go.
Hit it, machine girl.
Last week, the Perseverance rover began an exciting new journey, driving northwest of the Soroya Ridge. Perseverance entered an area filled with a diverse range of boulders that the science team believes could hold clues to Mars' early history. The terrain we are exploring is known as Megabreccia, a chaotic mixture of broken rock fragments likely produced during ancient asteroid impacts. Some blocks may have originated in a gargantuan Isidis impact event, which created a 1,200-mile-wide crater or about 1,930 kilometers, just east of Jezero. Studying Megabreccia could help us link Jezero's geology to the wider region around Isidis Basin, tying local observations to Mars' global history. The rover is now beginning a systematic exploration of these rocks, starting at Scotia-Fjellet. If they are truly Megabreccia, they could contain pieces of deep crustal material, offering a rare glimpse into Mars' interior. These rocks likely predate the deltaic and volcanic deposits we explored earlier in Jezero crater, making them some of the oldest accessible rocks Perseverance will ever encounter. They may therefore reveal to what extent water was present on ancient Mars, a key question as we continue our search for signs of past life on the red planet. In short, by venturing into this jumbled terrain, Perseverance is giving us a front-row seat to the earliest chapters of Mars' story.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
The probability of the Tesla Elon Musk launched into space will hit the Earth, or whether or not a Tesla will land on Earth from space, isn't something we normally be thinking about. But after Elon Musk actually launched one into space in 2018, it is something that some people are apparently contemplating. You may recall back 6 years ago the famous Tesla Roadster being launched into space on a rocket, and since then the Tesla has travelled approximately 15,715 miles per hour and covered a distance that would be the equivalent of orbiting the Sun 4 times over. But now that it's out in space, is there any risk of that Tesla falling back to Earth? And believe it or not, some scientists have already looked into this very question. In 2018, a study published in the journal Aerospace, yes, they've actually published the results. Some researchers likened the Roadster to an asteroid. The Roadster bears many similarities to near-Earth asteroids, or NEAs, which diffuse through the inner solar system chaotically, though repeated close encounters with the terrestrial planets and the effects of mean motion and secular resonances. A lot of technical talk for meaning that they come close sometimes to the planets. Initially, NEAs reach their orbits from the more distant main belt via strong resonances such as secular V6 resonance or the strong 3.1 mean motion resonance with Jupiter. How's that? When entering these escape routes, many NEAs are driven into nearly radial orbits that plunge into the Sun, and this would put NEA chances of colliding with a planet very low at around 2%. But the Roadster is slightly different. The 2018 article continued that the initial Tesla orbit grazes that of Earth, so one might expect an initial period of enhanced collision probabilities with Earth before it is randomized into a more NEA-like trajectory. It's therefore unclear whether the Tesla is likely to diffuse into distant strong resonances and meet the same fate as the wider NEA population, or whether it would first strike one of the terrestrial planets. The researchers estimated that the Tesla would draw closest to Earth in 2047, when it will come within 3.1 million miles of us. After 100 years, it becomes impossible to make long-term predictions. But that didn't stop the team from producing this statistic. They stated, however, using an ensemble of several hundred realizations, they were able to statistically determine the probability of the Tesla colliding with the solar system planets on astronomical timescales. With this longer timescale in mind, they estimated that there was a 22% chance of the Tesla hitting Earth. The researchers didn't exactly put a date on it, but at least we can relax given that this is on a time scale of millions of years, and that we shouldn't lose any sleep over a Tesla landing on top of us anytime soon.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Something has just been discovered, but it's been orbiting the Sun alongside Earth for decades, and will continue to do so for decades more. Our home planet just got a new companion, or at least, a newfound one. We know the Earth only has one true moon. But we've also known for a while that our planet is currently accompanied by 7 other small asteroids that seem to circle around us, even though they don't really orbit Earth as a true moon would. These objects, known as quasi-moons, tend only to inhabit Earth-accompanying orbits for short periods, years or decades, sometimes centuries. Now, it turns out, there's a new quasi-moon in town. Just discovered on August 29 by the Pan-STARRS Observatory on Haleakala, Hawaii, asteroid 2025 PN7 was quickly confirmed by other observatories. Earlier images of the object extend back to 2014. It now appears to have been on a quasi-moon orbit for about 60 years, and it will remain so for about 60 more. Eventually, though, it will revert to a horseshoe orbit, one that brings it periodically close to Earth only to back away again, never completing a full circle around our planet. Alan Harris of Space Science Institute, in a posting on the Minor Planets mailing list, writes that its velocity relative to Earth of 3.4 kilometers per second or 7,600 miles per hour is higher than would be expected from lunar ejecta. He adds that it's most likely just an asteroid that has trickled into a near-Earth orbit from the inner main belt. At some point in the future, gravitational interactions may eject it from Earth's vicinity altogether. Some future close encounter with Earth could put it on an orbit that intersects either Mars or Venus or both, Harris writes. Indeed, simulations carried out by French journalist and amateur astronomer Adrien Coffinet, who was the first to post on the MPML group that this object is a quasi-moon of Earth, show that, indeed, this object is likely to cross Mars's orbit at some point, although that event is likely thousands of years in the future.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. And just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our parent podcast Facebook page, which is Space Nuts.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
China proposes a flyby mission to the asteroid Apophis during the 2029 Earth encounter. Chinese scientists are proposing using a Pathfinder spacecraft to make a flyby of asteroid Apophis when it makes a close approach to Earth in 2029. The team behind the concept are proposing a Pathfinder spacecraft flyby of the asteroid Apophis during its close approach to Earth in that year, leveraging a proposed mission to deploy asteroid spotting spacecraft in Venus-like orbits. The mission would consist of 2 small satellites sent into a halo orbit around the Sun-Earth Lagrange point 1 to await the approach of Apophis and transfer into a flyby orbit so as to meet the asteroid shortly after its close encounter with the Earth. The asteroid is due to pass within the geosynchronous orbit belt on Friday, April 13, 2029. The Crown Apophis concept tags onto a proposed asteroid surveyor mission. That mission, named Crown, and for which the preliminary design is completed, would consist of 6 heterogeneous wide-field near-Earth surveyors in Venus-like heliocentric orbits and propose to substantially improve the searching and tracking of NEAs. It would, if approved, form part of China's asset for a planned comprehensive planetary defence program. The science objectives of Crown Apophis, according to Zheng Li of Sun Yat-sen University, who presented the proposal at the Europlanet Science Congress and Division for Planetary Sciences joint session in Helsinki, September 8, would be to measure the fundamental properties of potentially hazard asteroids and the effect of its close encounter with the planet Earth. It would aim to observe how the movement of material on Apophis is induced, any dust activity, and how it interacts with the terrestrial magnetosphere. The larger 44-kilogram spacecraft would use combined chemical and ion propulsion and carry a narrow-angle camera, microwave-ranging Doppler system, a formation monitoring camera, and a low-frequency radar. An 8-kilogram CubeSat would carry some of the same systems as the main spacecraft. This is a very rare opportunity for planetary science, and there are many parties already proposing missions or concepts, and so we don't want to miss this opportunity in China, Li said. Launch is proposed to be a yet-to-be-identified rideshare mission to geosynchronous transfer orbit, and then the spacecraft would slowly raise to reach its L1 position. We hope to coordinate with and complement other missions including Ramses, Destiny Plus and Osiris Apex, Li said, referring to respective missions from the European Space Agency, Japanese Aerospace Exploration Agency and NASA, which are in different stages of development, funding and operation in the latter case. Michael Nolan, who is the Deputy Principal Investigator of Osiris Apex, stated in an earlier presentation on the mission that congressional language in a bill not yet passed includes funding for Osiris Apex. Ramses faces its own funding decision in November at an ESA ministerial. Other smaller class missions in the US and Europe are being proposed. The value of multiple missions would be very high, according to scientists at EPSC-DPS. It's going to enhance our scientific returns, such as cross-verification and comparison. The results provide scientific context to each other and provide redundancies, Li said. He added that the team based in Macau has international partners from Brazil, Uruguay, Spain and France, but is also seeking further cooperation which would likely benefit the mission's chances of gaining approval, possibly by the end of the year. It is also looking at commercial avenues to make the mission happen. Li was also involved in another Chinese rapid response proposal to study 99942 Apophis, which would have employed a swarm of CubeSats to make multiple flybys. China is meanwhile working towards its first planetary defense mission, a kinetic impactor, with a combined surveyor spacecraft expected to launch around 2027. The country also launched a near-Earth asteroid sample return mission, Tianwen-2, in late May. China's first space mission to an asteroid was flyby of the asteroid Tutalus in 2012, conducted by repurposing the Chang'e 2 lunar orbiter for an extended mission.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Affirmative.
A distant supernova exposed elements from a star's core. The result reshapes ideas of how massive stars evolve. For the first time, astronomers have seen the inner layers of a star revealed in its final moments. According to long-standing theory, stars are built in layers like onions, with each layer composed of different elements that grow heavier toward the core. While this model is widely accepted, directly observing a star's deeper layers has been nearly impossible. Until now. Astronomers using the Keck Observatory in Hawaii have collected spectroscopic data from a supernova first identified by the Zwicky Transient Facility in 2021. The event, designated SN 2021YF, occurred 2.2 billion light-years away. The Keck observations revealed ionized silicon, sulfur, and argon, elements never before detected in a supernova because they are normally hidden beneath outer layers. The findings support some theoretical predictions about the structure of exploding stars but also raises new challenges. It is well established that massive stars shed material from their outer layers as they near the point of collapse into a supernova. This process has been documented many times, and the new data confirm it again. However, SN 2021YF appears to have lost far more material than any star observed before, leaving astronomers to reconsider how extreme this stripping process can be. The observations are presented in a new paper titled A Cosmic Formation Site of Silicon and Sulfur Revealed by a New Type of Supernova Explosion. The lead author is Steve Schulz, a research associate at Northwestern University's Center for Interdisciplinary Exploration and Research in Astrophysics. This is the first time we have seen a star that was essentially stripped to the bone, said lead author Schulz. It shows us how stars are structured and proves that stars can lose a lot of material before they explode. Not only can they lose their outermost layers, but they can be completely stripped all the way down to the core and still produce a brilliant explosion that we can observe from very, very far distances.
And there we have it, ladies and gentlemen, another episode of Astronomy Daily in the can. I hope you enjoyed the stories that we have for you today off the Astronomy Daily newsletter, which you can receive in your inbox every day just by putting your email address in the slot provided at astronomydaily.io, as I mentioned earlier on in the episode. I hope you go ahead and do that because there's lots of information coming in every day, stories from all around the globe. It's very interesting. Hallie and I get our information every day just like that, and I hope you do too. So join us again next Monday for the mostly human or mostly live version of Astronomy Daily. I'm live, she's an AI, and she gives me heaps. Okay, so we'll hope to see you then. Have a great week, and we'll catch you on the flip side. Bye, everybody.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.